Hello, I'm Eric Horvitz, Chief Scientific Officer at Microsoft. It's an honor to moderate a discussion on the future of search and recommendation beyond web search. I'm joined by four experts in the realm of search and retrieval: Nitin Agrawal, Soumen Chakrabati, Susan Dumais, and Zhang. Nitin is a corporate vice president at Microsoft, leading the engineering and data science teams responsible for Microsoft's search and AI-driven experiences across Outlook, Teams, and other Office 365 products. Soumen is a computer scientist and professor in the Department of Computer Science and Engineering at the Indian Institute of Technology, Bombay. He's best known for his work on the Clever web page ranking system and his work on focused crawlers and keyword search on graphic databases. Susan is a technical fellow and managing director of Microsoft's 3 Northeast research labs, including Microsoft Research New England, New York City, and Montreal. Susan specializes in research at the intersection of information retrieval and human-computer interaction. And Yi is a professor in the School of Engineering at the University of California, Santa Cruz. Her research interests include large-scale information retrieval, recommendation systems, internet advertising, data mining, natural language processing, and applied machine learning. Thank you all for joining me today. It's been amazing to see how central over the last 25 years that search and recommendation technologies have become, and their growing influence is now in all walks of life. My sense is that we're now at an inflection point with search and with waves of technical advances, like our rising ability to learn rich representations of text, images, code, and even physical processes and phenomena like molecular interactions and chemical compounds. So we see interesting directions from vertical search scenarios, and these include domains like biosciences or search within enterprises, as well as specialized context-centric search for information sources like email, video, and news. So I'd like to engage with our panelists today on technology trends and frontiers, key scientific challenges and advances on the horizon, as well as directions ahead with new experiences for search and recommendation. Let's jump in with some discussion. Susan, beyond web search is the subheader of this panel. We often think of search in terms of today's notions of web search, but there are many different data sources and tasks and many ways to design systems to help people to find what they think they're looking for. What will search and retrieval look like in the years to come, and where might R&D advances in retrieval take us? I know you have some visions about this. We've talked over the years. What IR experiences do we see on the horizon?
Yeah, so I think, as you said, Eric, people right now are really familiar with web search. It's quite literally transformed how people find information over the last 20 years. It's hard to understate how important that is, or overstate, I should have said. But web search has also limited how we think about search in the sense that we think what works for the web will work everywhere else. And so many domains are much less well studied than web search. You mentioned things like biomedical search, but it ranges from that to code to search in the physical world even. And search in these domains is really different than web search on many dimensions: the scale of the content, the availability of structured information, what it is that people are looking for, and the knowledge they have about content. Let me just say a little bit about email search, which I've studied for a few years now, and I know Nitin's really familiar with that. When you search over your own files or applications or email, one of the huge differences between web search is that you remember a lot about that email or that file. You might have remembered who sent it to you, roughly when it was, and so on. And so one of the challenges in search here is to help people articulate what they know about what they're looking for and provide them a way of going through results, really quickly. And so I think the fact that each one of these domains, whether it's biomedical search or email search, is different. And I think our jobs as people who develop both algorithms and interfaces is to understand what's unique about these and support people, again, in articulating what they're looking for and making sense of results.
Thanks, Susan. And so, Nitin, what do you see as the most important emerging applications for search and recommendation? I mean, we expect to see major growth over, let's say, the next 5 to 10 years and even further out.
Yeah, thanks, Eric. Over the last 5 or so years, I've been mainly focusing on the enterprise search. So maybe I'll give your answer in the context of enterprises. So I feel like Susan was saying before, that some of the technologies and experiences from web, they apply to the enterprises, but not all of them. So one challenge that I see in our workplace search today is when people are looking for information, they don't know which channel they receive that information from. It could be in email, it could be in a Teams chat, it could be in a meeting, a recording, it could be in a file. So we need to build these universal search experiences, which Bing and Google-like search engines have solved for web search, but the workplace search experience has not solved that problem yet. So I'm hoping, in fact, we are working on that we will create a universal search experiences. I think the other thing that I'm really hoping that in the next 3 to 5 years will enable is the summarization of the search results and the users being able to interact with the search results. So for example, I should be able to say, find me the video recording for a meeting I had with Satya on AI, and then I should be able to have a follow-on dialogue on what was Satya's comment about responsible AI. And that's something our customers in the workplace search cannot imagine or envision today, but I'm hoping that Microsoft will enable that, and the workplace search, these kind of experiences will almost become like a commonplace experiences, which it is not today.
Interesting. Soumen, deep learning has been, well, I would say, eating away at what we might refer to as the traditional components of search and retrieval systems. In your mind, what's the status and influence of deep learning in search per the components and pipelines for search and retrieval, and where are things headed with deep learning and other core technologies? I guess in short, what developments for search, what are some key developments for search amidst, I'd say, the crashing wave of neural models?
Thanks, Eric. So we all know that deep learning has been this enormous tsunami in the path of many research communities, including information retrieval and search. Deep learning has now taken over basically all the early stages of basic text handling and NLP, including multilingual processing, up to fine-grained named entity recognition, entity linking, and relation extraction. It's also used for deep passage retrieval, but that's not fully replaced classic text indexing on scoring yet. So going forward, I think what's going to change is that people are going to think of the basic unit of indexing and retrieval in different terms. So today, if you look at question answering or summarization, the unit of retrieval is a sentence or a span of tokens. That's roughly where most of NLP is operating today. But I will submit that knowledge graphs at very vast different granularities, from the web graph to something like Freebase or Satori inside Microsoft, right down to a person's personal information network, as Susan was describing. The set of people in my life, the emails they send, the documents we exchange, those are also nodes in a graph. And all of these can be featureized using deep techniques in different ways. If you look at automatic retrieval of bibliographic information from papers, those include tables and charts, which lead to graphs of their own. People doing drug design, they look at molecules also as graphs. And a very common paradigm is to search a large corpus of graphs for subgraphs that are approximately isomorphic to a small, possibly underspecified query graph. So I think neural technology will evolve far beyond the current generation of graph neural networks to implement soft, learnable matches between graph corpora like these. And the other thing that's going to improve a lot is that I don't think we're at the end of the road when it comes to using BERT or GPT or transformer-like architectures, because this one-size-fits-all, flattened, structure-oblivious, all-to-all multi-stage attention has very limited ability to generalize with data efficiency. So I think we need new architectures which are modular. End-to-end training is very overrated. That's not how humans learn. When we learned how to count we didn't say how many people were elected to the Congress this year, for example. That's a different counting task, but we can seamlessly adapt to it. So when it comes to like multi-clause complex question answering, we need modular and not end-to-end learning. And we need to put together these kinds of graph information, the personal graph, the global graph, rules of arithmetic, rules of inference, all together. And this is partly why in NLP and search, deep learning has not made inroads as quickly as speech and vision, because the role of symbolic and graphical reasoning is much more deep in the case of search and question answer. So that's how I think things will evolve.
Thanks. Yi, what's your sense for the most exciting and impactful scientific challenges today in search and recommendation? And what might breakthroughs on these challenges mean for capabilities provided to end users?
Thank you for the question. There are quite several challenges. Given the time, I will just list several really care about and I'm working on now. One is how to do conversational information retrieval and recommendations. In search, we generally believe user information needs are not expressed well. In conversational search or recommendation, then the system has the opportunity to elicit information from the user to resolve uncertainties through conversation. And so besides just finding information, the system can do things like grounding, disambiguation, decide what's the additional information to collect. Of course, the system also needs to face challenges to how to handle mixing initiatives between user and the system, handle multiple intents and things expressed by the user. And also, because it's conversation, the system needs to get user engaged in the conversation. And also need to handle exceptions and recover from failures. Natural language processing is not perfect. So all those sub-problems for conversational information retrieval. That's what people are working on right now. You are seeing more research in this coming out, research papers. And later, I feel in the future, there will be more advanced challenges we are going to facing. For example, the conversation agents need to do multi-step mathematical, logical reasoning, even planning or acquiring knowledge on the fly based on the conversation, acquiring skills and preferences from the conversation, and answer questions not just by finding the answer, but creating new information objects to answer through the conversation. That's more for the future.
Exciting directions. And while we're thinking about directions, let me just pivot a bit. So Yi, do you think some of these research pursuits are better suited for study at an industry lab or in academia, and why? Either one. And another related question is, and which goes hand in hand, and maybe I'll open this up to everybody too to start thinking about this, how can industry best support academics in doing cutting edge research on these challenges? Yi, any top level thoughts?
Sure. On the high level, of course, it's II is an area where both industry and academia works together, right? And on the other hand, there are differences between industry and academia, which is need to better handled by academia versus industry. I think it's case by case, and by analyzing what's the short-term and long-term benefits, the complexity of the problem, and the risk associated with it. For academia and industry are different. For example, the goal of academia and industry are different. Academia is focusing on when you join academia as a professor, the university wants you to build a researcher as a person. That's your primary goal. For industry, I think that's some good company also have that goal, but you have to benefit for the company, beneficial for the company, right? And that also has consequences about the risk tolerance and time frame of doing some things. Risk is less a problem in academia. It's totally fine if I do a research for 5 years then failed. That's okay. The university won't fire me for that. And so I think for high-risking, longer-term things and complex things that may not have short-term benefits is totally good for academia. Of course, I feel in search feel the industry might have more resources for certain problems, and you have wonderful researchers. And on the other hand, the academia has different strategic or perceived position in the human world versus industry. So some problem will be more appropriate for academia. For example, the bias and social responsibility of information retrieval and search and recommendation, academia could play some role there. Of course, it's also a problem industry cares about.
Let me ask the same question to Nitin, Soumen, and Susan. Feel free to jump in about the role of industry versus academia in pursuing these interesting challenges, problems over time.
Yeah, maybe I can start with that. So I think the first one is I'm going to repeat what Yi also said, that responsible AI is a big challenge for us to solve, and it's an unsolved problem. And I, as a person leading the team on the commercial side, I would love to collaborate with the Microsoft research and also with the academia to solve the responsible AI problem. I think what industry can do is to define a problem in a way that the researchers can collaborate with that. Sometimes, especially in the space of workplace search and recommendation, we have additional privacy and compliance challenges, which stops us from sharing the data and the user activities with even our own employees don't have access to that data in an eyes-on way. So that does create a challenge. But if the industry can define the problem and hand it off to the researchers, and if we can figure out a way to make use of the resources that we have in the industry, like the GPU compute, right? We have thousands of GPUs that our own engineers can use to train model. And the most importantly, we have the real-time feedback from the user, like the graph that some of you also talked about. I feel that the Microsoft 365 has probably one of the richest graph, the user content and user activities, user network. If we can figure out a way to identify a problem that the academia can collaborate with us in the industry, I think that could really help us move the needle.
And we have had some great experiences in the past with sharing out Bing logs to a community and having workshops and follow-up. That was really productive on both sides, I thought. Susan,
yeah, let me just follow on that. I think Yi and Nitin have hit some of the high points. I think one of the ways that we've long collaborated with universities is to have people, faculty visit, students visit, and get access to some of the some of the data that's really private in ways that we cannot share broadly. Internally, we can't look at queries or content of this private data, but at least you can look at some of the behavioral traces. And so I think working closely with academia is a huge thing that we can do. When the data is not private, and these are things we've done before. I think, Eric, you just released APIs to a search system that you built for biomedical retrieval. We've summarized some Bing logs or search traffic that people in academia have used. But I think we can also maybe think creatively, like some of the Trek studies or even Alexa Prize, to allow people to deploy algorithms in realistic traffic. That's something that I don't know that we've done, although others have looked at it. I think one of the things that industry has is certainly scale and behavioral logs, and these have really revolutionized how systems are designed, developed, and improved. But these kinds of logs only tell us a tiny part of what's going on in search, right? They tell us a lot about what happened, but they don't say anything about why people were searching, whether they were satisfied in the results, whether they were delighted in the experience, or they were, in despair. And these are really complementary perspectives on search that I think, as you said, folks in industry, in universities have done some really, really fascinating work in some of these problems that really help shape how one thinks about information needs and supporting those. So I think there's a lot we can do to work on some of the unique characteristics of enterprise systems, but there's so much more that can be done in complementary ways that I think it's a pretty great set of directions to pursue.
Let me throw out a question to all of you, and this came up a few minutes ago in comments. So search ranking and recommendation engines clearly have had major influences on people's beliefs and actions, including what media they consume for news and entertainment, where and how they spend their money, the votes they cast in elections. What are your reflections on key challenges and directions for researchers in academia and industry in the realm of what we'd call the responsible development and fielding of search and recommendation technologies? Anybody feel free to jump in with thoughts.
Yeah, maybe I'll say something about, I think figuring out what is the objective answer to a specific question, like what's the height of Mount Rainier, versus a subjective question about, what are the side effects of a medicine, or what's the meaning of life. I think solving that problem is an important one. How do you actually understand the difference between the factual, objective versus subjective? And we do have that challenge in our products, and I think it aligns closely to what you are saying. So that definitely is another problem that maybe the academia should collaborate deeply with the industry to solve that.
Okay, so Nitin's punting things over temporarily, at least for discussion, to academia. Yi or Soumen?
Sure. It's interesting. I do care. In academia, we care, like you too, care about the bias and social responsibility of AI system and search engines. As you said, because the search results ranking could dramatically influence people's viewpoints, and also recommendation system dramatically change people's choices. Because that's human nature. We collect information, and we make predictions based on the information we collected, and then we take actions based on our prediction about the future, right? That's why information has dramatic influence on the society, on what we do. And however, it's very difficult to have unbiased information source. There are various reasons, and it's first, actually, this bias, this definition of bias is arguable. People has been arguing about what's bias, what's not bias, and for even before computer science emerges, for thousands of years. And so people's definition of bias is very heterogeneous. And on the other hand, even if we agree on bias definition, there are various different definition of bias. In the search system, we could have bias emerging because of various reasons. In order to solve the problem, we have to understand where the source of the problem. For example, the test collection for evaluation could be built with bias introduced by the information source or user behavior bias. And the evaluation measure, which is very extremely important in search engine and recommender system. That's what our system are optimizing for, are built on user models, and which could be biased. And so in order to tackle that, we need to solve those individual pieces of the system. But on the other hand, I generally feel it's probably a problem that we will keep on arguing and working on forever.
Yeah.
Like in the past 1,000 years.
Well, very challenging directions. I know, Susan, you've worked on introducing or injecting diversity of viewpoints as one approach to addressing robustness of viewpoint and consumption of different viewpoints. Any comments on?
Yeah. So, I mean, first of all, I agree that that we need to do a better job of providing people with and explaining to people how the results come about. And so there certainly is a lot of work in multi-objective optimization. And, it's really clear that if you look at, web search, from day one almost, there has been diversification of search results that based on site collapsing. You don't give 5,000 results about Microsoft that come from Microsoft.com. So since the very beginning, people have been collapsing across sites and showing a variety of different sources of information. Bing has experimented in the past on things like explicitly showing pro and con on topics that might be controversial, on providing information from different sources. And so I think there are some algorithmic ways to approach some of these, and a lot of it will have to come with some of the topics that came up during the session on search, summarization, and sense making. I mean, providing people with ways to look for different perspectives and information. So there's certainly some that can be done algorithmically, but the content that we're dealing with reflects a lot of biases and prejudices of the people who are authors of it, and it's really, really challenging to think about how to make progress in those areas.
Soumen, any thoughts you've had about this topic?
Yeah, so in the early days of search engines, people thought that with link-based ranking, web spam would become history. But the world quickly adapted to link farms and things like that, right? And then we had to scramble to detect link spamming. So this is an ongoing struggle, and I think fairness of representation is very fundamental to this. If some entities on the social network are having disproportionate influence, one has to make sure that the influence is backed by authority. That we don't take advice on medications from a celebrity or a movie star, right? Or we don't resolve important debates about politics and society based on advice given by people who are not experts in that area, right? So I think this business of detecting anomalies in various ways, right? So where is the network evolving, spatiotemporally? Are there communities which are swinging their opinion from one extreme to the other faster than you'd expect, given historic trends of people convincing each other? I don't think there's a fully automated or mechanized solution to this, but we need tools to detect, things like oscilloscopes and multimeters over the social network evolving in time, and how they're exchanging messages to figure out if there is some kind of disproportionate representation going on somewhere. So I think that's very important to detect.
So, Soumen, I like your comment on anomaly detection, because that's certainly an anomaly in terms of behavioral patterns and of interaction and influence. It's certainly something that's really prevalent in email spam and web spam.
Yeah, interesting. Hey, we just have a few minutes left, and I'd like for all of you to reflect about grand challenges in search and recommendation. What are they? Does anyone have a favorite? If the community were to, let's say, focus on a grand challenge in this space, let me just go around the horn here. Soumen.
Oh, my reading list is out of control. Have you looked at archive lately? Right? So just as we were discussing prior to this session, if we say, well, deep learning was quickly successful in some areas, but it took a while for it to show impact in standard retrieval. Why is that? Can I ask queries at the level of, you said it changed last year. Can you summarize the design innovations of networks that made it happen? Which groups made it happen? How did the networks differ fundamentally from basic transformers? Did they do something special? So trying to agglomerate and understand a whole bunch of papers.
It's a great challenge. Susan.
Yeah. I have so many of these. I'm going to.
I realize this is the pop question, so
I have so many things that I think are really big challenges. But let me say one that I've thought a lot about for 20 years, and it's only gotten more complex than less complex. Nitin alluded to how in enterprises we need to not worry so much about which applications people use to create information, but provide access to it. I think it goes well beyond this. I mean, there are so many silos of information now, whether it's information on the web or enterprise systems. Think how many apps we use daily. Even the physical world is increasingly digitized in interesting ways. Wouldn't you love to be able to do Control F in the real world? And so I think that, particularly interesting partition of this is providing personal information spaces, that is allowing people to get back to things that they've seen regardless of where they saw it, and just not having to worry about it. I think the next generation of searchers is probably closer to that. They save stuff somewhere and use search to find it. And so I think we need to start bridging those information silos to do that for everyone.
Thanks. Nitin?
Yeah, so my grand challenge for my area, which is, let's say, workplace search and recommendation, is to be able to figure out how to combine the content-based large models and the activities-based large models. So like for example, in Office 365, for an organization like Microsoft, we have like 200,000 plus people collaborating with each other on thousands of channels and groups and SharePoints. And each of that activity is sort of an edge in a graph or that node. We should be able to create the node embeddings and use that for both search and recommendation. So like in the web search, in addition to content, link plays a big role. We don't really have the luxury of having the anchor text and link graph for the workplace search, but we do have this activity graph. And at least we have not made a great use of that yet. So I would love to pose that as a grand challenge. How do we create the combination of content-based embeddings and the graph-based embeddings to create new search and recommendation experiences? So that's my grand challenge.
Thanks, Nitin. And Yi, you have the last word.
Thank you. I want to work on that problem.
Okay, we're done.
Have some students working on that. Okay.
That's one of the reasons I'm here on this call, Yi. So yeah, let's do that.
That's fabulous.
There are quite, as Susan said, there are very different challenges. And I think it's good for the community to have embrace diversity problems and don't just working on one challenge problem. Right? And for myself, I'm interested in personalized conversation in search and recommendation agents. And that can, currently people have been doing that more on closed domain, like a particular domain, and do a lot of customization. And it's interesting to study what can be generalized. Like search engine is web search is pretty generalized. How about conversational information virtual assistant? What can be generalized and what need to be customized and how to support that? And you can use it in text scenario, in voice, over the voice, or in situated search, like a multimodality based. For example, even I know Microsoft have Xbox. Xbox in the future could be a search engine.
Okay, well, great. Well, thanks so much, everybody. Thanks, Nitin, Soumen, Susan, and Yi. It's been an interesting and certainly fast-paced discussion. And we only had enough time to hear some of your top-of-mind thoughts, but I found your ideas inspiring, and I'm sure the viewers will as well. Research and development is certainly moving fast with search and recommendation. It's going to be fun to see where things go. So thank you all again for sharing your thoughts with us today.
Thank you.
Thank you for inviting.